Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to start a video series which is an upgrade to an old video that I had a long time ago. It was based on the ISA, PCI, and the LP, I believe it was the LPN or what, LPC or whatever the heck it was. It was a low pin count. That's what it was, low pin count. And in this particular video, because I'm doing this as a three-part update to that, any mistakes that I make in this particular video, I'm going to address in the next video. Okay? So I'm going to take you through this slowly, step by step, piece by piece, and we're just going to wing it from here. I have a whole ton of notes. I know I tried to do this on my last live stream and it didn't go so well, so I'm going to try this again and we'll see if I do any better. Alright, so if you have any, if you find any flaws, you can leave them down here in the comments below. Before I begin, I wanted to let everybody know that I have actually written 5 Kindle books. And if you are interested in any of them, let me know, and I will send you links to the I'll send you a link to the latest Kindle book, and you can read that one first, and then you can read the rest of them at your own leisure. There are 2 more coming up. I just don't know when. Hopefully, it'll be done by the end of 2023, but it may not. We'll see. All right. In the early days of computers, there were no sound cards, graphics cards, or extra slots of RAM. As a matter of fact, a real computer in the early days of computers didn't even have a monitor or a keyboard. They were simply boxes that were connected to dumb terminals with very large wires. And I know this because I actually worked on an NCR mainframe back in those days, and that NCR mainframe, there were no monitors, there was no keyboards, nothing. The dumb terminals had monitors and keyboards, but not the actual machine itself. It was a completely separate unit. Okay? Now, when I was in high school, I also used the Tandy Radio Shack 80 computer. And those computers were actually networked together. Now, the TRS-80s, as they were known at the time, they did have monitors and keyboards. Yeah, you didn't want to see those. Those were horrible. And the keyboards were monochrome, and of course the keys were just, yeah, they were keyboard keys. Okay? Now, the Tandy Radio Shack 80s, or the TRS-80s as they were known at the time, they actually had slots for RAM sticks, but the keyboard and monitor were attached to the motherboard with a wire. Okay? So if the keyboard or the monitor stopped functioning, you had to either replace the wires or you had to replace the motherboard. Okay? At the very least, you may also have to replace the entire keys on the keyboard because maybe one of them doesn't work. You might have to pull the whole board off just for that. So it was quite a mess. Okay? But this horrible computer situation changed when IBM released their first personal computer. How did this situation change? Before I tell you the answer to that question, I have to introduce you to the etymology of the word peripheral. The etymology of the word peripheral comes from the Greek word peri, which means round or a round, and the Greek word pherion, which means to carry. This word was originally a geometric term, and that should sound familiar to you if you are one of those people who watched all of my Euclid videos, and I hope that if you have not yet, you do. How does this apply to computers? A peripheral computer device either sends information from a computer user to a computer or sends information from a computer to a computer user. Basically, a peripheral device is a computer input-output device. And in the early days of computers, this became a huge problem. Each computer company developed their own keyboards, their own mice, their own monitors, etc., etc. And you couldn't swap a computer keyboard or mouse between computers that were manufactured by 2 different companies. Just couldn't be done. Then IBM came along with what was called the Personal System 2. That's what the PS2 was called. Also, IBM designed a set of standards. That way, if your computer keyboard malfunctioned, you didn't have to send your entire computer to a company for a costly repair or buy yourself another computer. You could just simply take whatever part was malfunctioning off the computer and then throw it in the trash and put your new part on. So if your keyboard was malfunctioning, you just unplugged the wire from the back of the computer, took the keyboard, pitched it in the trash, brought in your new one, set it up, plugged the wire in, and you were all set and ready to go. Now, when IBM designed these computer standards, they designed something called the Industry Standard Architecture. This meant that third-party companies could manufacture keyboards and monitors and other devices that you could actually attach to your computer without having to buy a whole brand new computer or replacing the motherboard or some funky thing like that. This technology lowered the price of computers significantly. And Industry Standard Architecture later became, through an acronym, ISA. That's what it was. Now, at this point, I have to briefly discuss the PS2 computer port. The PS2 port is a 6-pin mini DIN connector. At this point, you may be wondering what the acronym DIN connector is. The acronym DIN stands for Ducetti's Institut for Nuremberg. And I'm going to put that particular set of words in the description box. You can look this up for yourself. This is a German way to say things, okay? The English translation of that is that this was the German Institute of Standardization. Okay? So, the German Institute of Standardization created this DIN connector. Okay? These PS2 6-pin mini DIN connectors had the following pins. It had a data pin, a ground pin, 2 reserve pins, a clock pin, and a 5-volt pin. And if you're an electrician, that means a lot to you. If you're not, well, it's not going to mean very much. When IBM originally released the 6-pin mini DIN connector, they directly attached it to the motherboard of the computer. Now, there were some advantages to this kind of keyboard and mouse connection. This connection didn't require computer drivers to work. That came in handy. That means you could use these keyboards regardless of which operating system you were using. Now, at the time, there was basically about 2. I know IBM kind of had their own 2, but they all actually worked with Microsoft. So you could have your IBM OS, or you could have your Microsoft OS, which really was a DOS at the time, then became an OS because they didn't use disks anymore. Okay? Because DOS was disk operating system. Okay? They just eliminated this, so now it's just an operating system. Okay? Now, another thing that this DIN connector meant for computers was that a keyboard would always work unless this port was physically damaged in some way. The mini DIN port was also the first thing a PS2 computer would detect before it activated the BIOS, which is the beginning input and output system. Okay, or I know it's basic input output system. It depended on what computer you were working with. Like I said, the oldest computers, when they mentioned BIOS, they meant beginning, because after all, that was the first thing that ever started up. But on the more modern ones, it's the basic input-output system. Whatever. For the layman, that's not going to mean a whole heck of a lot. For a computer expert, that might mean a lot, but for a layman, that's just not going to mean all that much. So, what would happen is that before your computer actually used the BIOS, okay, they would first detect the keyboard. Okay, your CPU would detect the keyboard, then it would detect the BIOS. Okay? So, because of this, Because your computer keyboard would work with your computer regardless of what was going on with your BIOS, you could actually fix your BIOS with your computer keyboard because it was operating separately from the BIOS. There were other advantages to having a mini DIMM PS2 port on your motherboard, but these advantages could quickly turn into a nightmare if the port was physically damaged. If you could remove the port with special computer tools, you could just simply replace the port. However, how many businesses back in those days actually possessed the tools necessary to replace that PS2 port? Yeah. So, what would happen if you didn't have these special tools? Then you'd have to seek out another option. At first, IBM and Intel didn't provide any other options. You took your computer to the shop, and they physically repaired the port, and there you go. That could be expensive. But this would change with the advent of the ISA card slot. As I stated earlier, there were many devices that could be attached to an ISA bus. You could attach a new hard drive, a graphics card, or a sound card to an ISA bus. The ISA bus made it possible for a computer's CPU to communicate effectively with all of its devices. So who created this ISA bus? Not butt, but bus. Okay, who created the ISA bus? Well, the IBM Corporation hired a research team. The leader of this team was named Mark Dean. His team created a bus that supported one of the first modern Intel microprocessor. This processor was called the Intel 8088. This bus transferred computer instructions at a rate of 8 bits per second. But Intel was already developing a more advanced CPU architecture, so Mark Dean and his research team developed a 16-bit ISA bus to match the more advanced Intel CPU architecture. The ISA bus permanently changed the motherboard architecture because you could actually add an ISA board to an ISA slot. You could really improve your computer dramatically. Before the ISA bus was created, a simple cord connected a computer keyboard to a motherboard, as I was explaining earlier in this video. This was also true of computer monitors, mice, and other devices. When the IS bus architecture was developed, special slots were attached to your motherboard. These slots were called ISA slots. So if one of the ISA slots malfunctioned, an ISA-compatible card could be placed on another ISA slot until the motherboard could actually be fixed. Could someone back in the day purchase and then install an ISA card with a Min DIN 6-pin PS2 port attached to it? It is entirely possible that could have been done. Now, when IBM first released these things, these computers, that wasn't even possible because that was at the beginning of their technology. But when they started getting to 16-bit architecture, it could have been possible. Now, I tried to do some research on this, and I actually found some boards that are in existence today. They're mostly PCI boards, but they do have the mini DIN 6-pin PS2 ports attached to those ISA boards. Okay? Well, they're PCI boards, but I actually did find one that was actually an ISA, believe it or not. It was a custom job, but it was definitely ISA. So, at some point when these generic manufacturers were given permission by IBM to create such things, that's probably what they did. How far back this goes, I don't know. That's something I'll leave to you guys to research to see whether they actually pulled it off or not. Since they actually have PCI boards that do this, I can only assume at that time, as soon as they went 16-bit and IBM was a little more relaxed about the architecture of their computer, it's entirely possible they could have created ISA boards with those mini DIN 6-pin PS2 ports. We'll have to see. Now, where's the proof that these PCI boards actually exist? Well, I'm going to leave those right down there. There's articles, web articles. There's a whole ton of them. And one of them, at least one, if not more, show you that, yes, they have actually created PCI boards with these mini DIN PS2 whatever board, slots. Those exist. At least today they do. So how did this ISA bus actually work? Well, the main thing to show you here, I know this is a graphics card and not a motherboard, okay? I don't know what happened to my old motherboard, but it's gone. But anyway, I've moved a couple of times, so you can about imagine. But anyway, as you can see here, and I think you can see this board has copper on it. And that's going to come very important as I continue this discussion. Okay, so you actually see that this is an actual graphics board, has copper on it. Alright, there's actually copper on motherboards too, and I'll get into that in just a second. So how did the ISA bus work? The first thing you must know is that all motherboards are made of fiberglass. That's right. And not just motherboards, this board is also made of fiberglass. That is true. This fiberglass is made from sand that has been transformed into molten glass. The sand is subjected to extremely high temperatures to form the molten glass. Then the glass fibers are extracted from the molten glass to form fiberglass. Then a sheet of epoxy resin is applied to the fiberglass. When this epoxy resin is exposed to heat, chemically speaking, it becomes very, very hard. The chemical process is called curing. Several sheets of epoxy resin and fiberglass are stacked together to form the base of the motherboard. Once this base is formed, the board is laminated. Sheets of copper foil are applied to both sides of a motherboard. As you can see here, there actually is some copper on this motherboard. You'd have to see it big time to see this. But there is some copper on here. You'd find that on motherboards almost immediately. Okay. Once the copper is placed on the motherboard is heated again. This causes the copper foil to permanently attach to the motherboard. But there is one more step that has to be performed on the motherboard for it to function properly in your computer. A photosensitive material called photoresist is applied to both sides of the motherboard. It's exposed to ultraviolet light, and then any excess copper is just simply washed away. Now, if you want the exact details about all this, you can take a look at the links down below to read the web articles that discuss all this. Why is all of this so important to our current discussion? Because copper is a good conductor of electricity. But this isn't the end of the ISA story. Recently, I uploaded a video about computer RAM. Do you recall when I discussed electrons and capacitors? This is why you need to know about the layer of copper which is attached to the motherboard. Any computer bus will carry data. What's data? Electrons. They carry it from the CPU of a computer, ta-da, CPU, to other devices to attach to the motherboard. This would be keyboards, this would be mice, this would be monitors, etc., etc., etc. And where does the CPU of a computer obtain its electrons? It obtains them from the power supply of the computer. That's where it gets it from. But I have to introduce you to yet another computer term before I continue this particular discussion. And that computer term is frequency. You've heard that word before. If you watched my sand battery video or my stereo speaker videos, you know what I'm talking about there. The CPU of any computer contains transistors. When a computer executes an instruction, some transistors are opened and others are closed. When the transistors are closed, they hold on to electrons. When they're open, they release those electrons. This affects the flow of electrons inside of a CPU. It also affects the flow of electrons throughout a whole computer, too. The frequency of a CPU is measured in hertz. A hertz is some event that occurs every second. As I stated earlier, every time the CPU performs an instruction, transistors inside the CPU open and close. One computer instruction equals 1 hertz. So if a computer is performing 6 instructions, then the computer is running at 6 hertz. If a CPU is performing 1,000 instructions, then it's operating at 1 kilohertz. And if a computer is performing 1,000,000 instructions, then it's operating at 1 megahertz. That's how that's measured. Do you recall a video series I uploaded recently about how to turn a stereo speaker into a heater and air conditioner? Have you ever heard of an FM, AM radio broadcast? Sound waves and computer clock speeds operate in a similar way. Not exactly the same, but similar. If you want a more detailed presentation about CPU clock speeds, read the web article down below. With all of this in mind, I can finally finish my discussion about the ISA bus. A computer CPU isn't the only component on your motherboard that is measured in frequency. An ISA bus is also measured in frequency. In this case, the frequency of an ISA bus refers to how fast data is transferred from a peripheral to a CPU, or how fast a CPU sends data to a peripheral. It doesn't refer to how much data is sent between the CPU and the peripheral. Okay? It just refers to how fast that data gets from the CPU to the peripheral, or from the peripheral to the CPU. Now let me illustrate this. Let's say a person places a toy into a box and some shipping company picks up the box from the person. And let's say that the shipping company is very fast and able to deliver the box to another person in less than 10 minutes. Well, that'd be great. Don't you wish your shipping companies could do that? This would be truly a fast shipping company. The 10 minutes would be the frequency. Okay? But what's in the box would still be the toy. In this case, the toy would be the bits that were shipped from the first person to the second person. Now let's focus on the width of the ISA bus. Normally people would think of a data bus as a set of wires. There would be one wire that would send information from a peripheral to a CPU, and another wire that would allow the peripheral to receive information from a CPU. But as I clearly explained earlier in this video, there are no wires on the motherboard. There are only strips of copper attached to the motherboard. The more copper strips that an ISA bus contains, the more information that can be sent back and forth between the CPU and all the peripheral devices on your computer. And I also stated that this information would be in the form of electrons. That's why I referred to RAM capacitors as electrons. So when you type on your keyboard, you are sending electrons across from the keyboard, which is a peripheral device, to your CPU. This is also true of electrons being sent from the CPU to your computer monitor, mouse, or even keyboard. Many people compare these copper strips on a motherboard to lanes of road on a highway. And this does affect the speed of electrons that travel from the CPU to the peripheral. If these copper strips become clogged with electrons, then the electrons won't travel very fast. Notice how I use the word fast. The speed is measured in hertz. This is why bus width is associated with term hertz. I have a web article in the description below that will discuss all that too. I could go further with this discussion by presenting the terms parallel bus and serial bus, and I may upload a video about that in the future. But for now, I will leave you a web article that explains those two particular terms, so you can go look those up for yourself. So when people are discussing an ISA bus, a question has to be raised. Why do they refer to bits and bytes when they discuss ISA buses? Allow me to explain that one. Let's suppose the CPU decides to send 8 bits of data to your computer monitor. Your ISA bus has an 8-bit width and operates at 4.77 megahertz. So what you would do is you'd multiply the 8 bits with the 4.77 megahertz. When you do, you obtain a result of 38.116 megabits per second. You could also say that you are able to send approximately 38 bytes per second across your ISA bus. This might sound fast, but if you compare that speed to a modern-day computer, you quickly discover how slow that speed really is. Yeah. You'll find out soon enough. But let's go on. Now, I have more web articles I want you to read, and they're going to be right down here in the description below. When ISA bus and slot technologies were first released by the Intel Corporation, they had an 8-bit width and a 4.77 MHz architecture. But the Intel Corporation finally increased the ISA bus width to 16 bits. So why did I experience a keyboard lag time on the first computers I programmed on? Well, you got to keep in mind that the ISA bus speed isn't the only factor when it comes to lag time. Remember that CPU is opening and closing transistors. Okay, they are receiving data and sending data. And they may not be receiving and sending data just from your keyboard. They receive and send data to your monitor. They send and receive data from other ISA components, that kind of thing. Even your RAM sends and receives data. Now, every computer I've ever programmed on had an operating system. This operating system told the CPU how to receive, process, and send data through the motherboard. So the CPU of your computer isn't just sitting on a chair waiting for you to send data to it. Not at all. Oh, what the? What the? Stand by. All right. Whew. Sorry, the computer went buzzy on me. Now, the operating system was not the only thing that CPU was operating at the time. If you're running software like a database or a spreadsheet or a word processor or anything like that, that was running on the CPU as well. Okay? So that meant a lot of data had to pass through all these computer buses on the motherboard. So the CPU of your computer and the programs that are processing through the CPU of your computer can cause lag times when you're typing data into a computer. This is the same thing as what you experience on modern computers today, especially if you have a lot of programs running in the background. It can take up a lot of CPU and RAM, so there you go. Of course, the Intel Corporation continued to develop faster and faster CPU architecture. Now, because of this, they also had to develop faster and faster ISA buses. This forced a group of computer companies, who were called the Gang of Nine, to develop extended industry standard architecture. When IBM itself replaced the ISA bus with something called the microchannel architecture, other computer manufacturers developed more advanced EISA, which is extended industry standard architecture, and VL bus architectures to compete with IBM. Computer technology rapidly developed, and finally the Intel Corporation released a product called the PCI bus. And I will cover that in a future video. So, thank you very much for all your patience and all your time. I will tell you more in a future video, so I'd like for you to stay tuned.